In this video, we're going to go ahead and review some concepts from 6th grade together. Now, if you'd like to download a free copy of this blank PDF or the annotated answer key PDF, you can find a link to that below. To get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. In number 1, it looks like we have a fabric that has a length of 3/4 meters. We're going to go ahead and cut this fabric into little pieces, and each of these pieces is going to measure 1/12 meters long. The question is which of the following expressions can be used to determine the number of 1/12 meter length pieces that we can cut? Now, I think a great strategy for a problem like this is going to be drawing a picture first. All right, so let's just say this is the entire fabric, and we know the length of it is 3/4 meters. And if it's 3/4 meters long, that means we can cut it into 3 equal sized pieces that are going to be 1/4 meter each. So that was a rough estimate in me cutting it into quarter sized pieces. And what I'm going to do next is take this 3/4 and rewrite it in terms of twelfths. So we're going to have 9/12 meters, which is an equivalent fraction, but you're going to see that that's going to be helpful if we're trying to cut our pieces into twelfths as well. And so if you go ahead and take each of these fourths and you rewrite them in terms of twelfths, then you're going to see these little pieces here. And so each of these little pieces is going to represent 1/12. So the question is how many of these little 1/12 size pieces can you fit into the 3/4? Now, hopefully it makes sense that whenever you're trying to figure out how many times something fits into something else, the operation you should be using is division. In this particular problem, we're trying to see how many of these 1/12 size pieces we can get out of the 3/4 meters long fabric. Now, hopefully you can see that you can fit 1, 2, 3, 4, 5, 6, 7, 8, and 9 of these in here. And if we actually go ahead and complete the algorithm here, let's see what that's going to look like. If we take the 3/4, which is the entire fabric, and we divide that by 1/12 to see how many of them fit inside. Keep in mind when we divide, we're actually going to take that first fraction, multiply by the reciprocal of the second fraction, so that's going to be 12/1. Then we can go ahead and either just multiply, cross, and simplify, or we can go ahead and cross cancel. The 4 and 12 have a common factor of 4, so we can make this a 1 and a 3. And so when we write this, it's going to be 9/1, which is just equal to 9. And so from that 3/4 meters fabric, if we are going to cut a bunch of little pieces that are 1/12 of a meter each, we could cut 9 of those pieces of fabric. All right, here is another problem. In number 2, let's go ahead and find the product. Now keep in mind when we find the product of these numbers, we're going to be multiplying. So what we're going to do is take the number with more digits and put that on top. We're also going to ignore the decimals here. So we're going to go ahead and say, make this number 100 times too big by getting rid of that decimal. And let's go ahead and make the 7.9 10 times bigger by getting rid of its decimal. Let's just go ahead and multiply these whole numbers and then make our product later on 1,000 times smaller. So then we go ahead and start with the ones place here. So 9 times 7 is going to be 63. We'll go ahead and carry the 6. 9 times 4 is going to be 36, plus the 6 is going to be 42. Put a 2 and carry that 4 here. 9 times 3 is going to be 27, plus that 4 is going to be 31. So we'll go ahead and put that 1, carry the 3. And then 9 times 6 is going to be 54. 54 plus the 3 is going to be 57. All right, now we're done with this 9. Let's go ahead and cross out each of these values. And let's move on to using this 7 over here. The 7 again is really 70, so keep in mind that we need to know that there's a place value here. 7 times 7 is going to be 49. We'll put the 9 and carry the 4. Then 7 times 4 is 28, plus that 4 is going to be 32. Carry the 3. Then 7 times 3 is 21, plus the 3 is 24. Carry the 2. And then 7 times 6 is going to be 42, plus the 2 is going to be 44. All right, so we have our 2 partial products here. Let's go ahead and find the sum of these partial products. So 3 plus 0 is going to be 3. 2 plus 9 is 11. Carry the 1. 1 plus 1 plus 2 is going to be 4. 7 plus 4 is going to be 11. We'll carry the 1. 1 plus 5 plus 4 is going to be 10. Carry the 1. 1 plus 4 is going to be 5. So this would be our product if we were just dealing with whole numbers. But keep in mind that we actually made this decimal 100 times bigger when we ignored the decimal, and we made this 7.9 10 times bigger by ignoring that decimal. So in the end here, if we move the decimal over 3 times technically in the beginning by multiplying by 1,000, we have to go ahead and divide our product by 1,000 here to take that into consideration. So our product here is going to be 501.413, or 501 and 413 thousandths. This would be our product. All right, here is number 3. In number 3, a particular ordered pair has a positive x coordinate and a negative y coordinate. Which quadrant is this ordered pair located in? So if we're going ahead and taking a look at a coordinate plane, we can go ahead and see what this would look like. So here we have our x-axis and our y-axis. Here's x, here is y. Keep in mind that in quadrant 1, we have positive x values and positive y values. In quadrant 2, we have negative x values and positive y values. In quadrant 3, we have negative x and negative y values, and in quadrant 4 we have positive x's and negative y values. So when we took a look at the 4 quadrants, here is going to be quadrant 1, here is quadrant 2, quadrant 3 is over here on the bottom left, and quadrant 4, which is that IV for Roman numerals, is going to be in the bottom right. So if we happen to have a positive x coordinate, then we know that we have to be on the right side of this coordinate plane. And if we know that we have a negative y coordinate, that means that we have to be in this bottom right quadrant. This is going to be quadrant 4. So if we have a point with a positive x and a negative y, we know it must be located in quadrant 4. Here is number 4. In this problem, we're told that in total there are 56 tennis balls and lacrosse balls altogether. So the ratio of lacrosse balls to tennis balls is going to be 5:3. Determine how many tennis balls and lacrosse balls there are. Now let's go ahead and set up some ratios here. So I'm going to set up and say that I'm going to put tennis first, and I'm going to put lacrosse second. So I'm going to write tennis, and I'm going to write lacrosse, and I'm actually going to write another one, and that's going to be the total. So I know it's a little weird to have these 3 fraction bars, but that's perfectly fine, I think, just to organize our information. So our ratio here is going to be what? Well, for each of these, for tennis balls, it looks like the ratio we said was going to be 5:3. So we're going to go ahead and write that down in fraction form, and you can use colon form if you want to. Now, if that was 5:3, what would the total be? Well, the total would be 8 here, right? If you had 5 plus 3, that would be 8 total of them. So if I asked you what was the ratio of lacrosse balls to tennis balls, you would say 3:5. If I said what's the ratio of tennis to lacrosse balls, you would say 5:3. If I said what's the ratio of tennis to all the balls, if this was the case, it would be 5:8. If I said what about the ratio of all the balls here to the lacrosse balls, it would be 8:3. So the way I wrote it might be a little bit strange, but feel free to write it in a different way if that makes more sense to you. We're told here that we have 56 total of these balls, and we have to figure out how much of the other ones we have specifically. Now, we were told in the problem that there were 56 tennis and lacrosse balls altogether, so we have to take that information into account. That's not just the tennis balls and not just the lacrosse balls, but it's the total. So somehow from 8 here, we need to get over to this total amount of 56. Right? So how does 8 become 56? Well, somehow it got 7 times more for the total amount here. So we have to use that same value to keep the same ratios here. So we're going to have 7 times more of each of these types. So 5 times 7 means that we must have 35 of these tennis balls if this was the case to keep the same ratio. And then 3 times 7, that's going to be 21. Then we must have 21 of these lacrosse balls, so that altogether we have a total of 56 of these, right? So if we take a look here, the ratio of 5:3, if we write this, is the same thing as 35:21. And if you add 35 and 21 together, you still get 56. And so keeping the same ratio of 5:3, if there were a total of 56 lacrosse and tennis balls altogether, 35 of them must be tennis balls and 21 of them must be lacrosse balls. Let's check out number 5. In number 5, if the area of a rectangle is 25.5 meters squared, determine the width of it if the length is going to be 5 2/3 meters long. Well, let's go ahead and label some information here. So using that first bit of information, the area here is going to be 25.5 square meters. I'm just going to write 25.5 for now though. And the length here is going to be 5 2/3 meters. All right. So let's keep in mind what the formula is when we're finding the area of a rectangle. We'll try to remember that when finding the area of rectangles, the area is going to be equal to the length multiplied by the width. So we have the length here, and we're going to go ahead and multiply it by the width. Now, in this particular case, we know that the area is going to be 25.5. Now, I'm going to go ahead and write this as an improper fraction right away. So if we go ahead and take this 25.5, 25 times 2 is 50, plus the 1 is going to be 51. So another way to write the area here is going to be 51 halves. And that's going to be equal to the length. Well, I'm also going to go ahead and take this length and write it as an improper fraction. So 5 times 3 is 15, plus the 2 is going to be 17. So that is going to be 17/3. And we're going to go ahead and multiply that by whatever the width is. So I'm just going to write W here. Now, you don't have to write that dot there for multiplication because it's implied, but I'm writing it anyway. So when we're finding the area, you multiply the length and the width to find out that area. But in this case, we know that the area is over here, and we know that the 17/3 multiplied by the width gets you that. So to get the width here, let's just go ahead and divide both sides by the 17/3. If we divide both sides by 17/3, then on the right side, we're just going to be left with the width, and that's going to make sure that we can solve for it on the left side. So let's go ahead and divide both sides by 17/3. On the right side, the 17/3 divided by 17/3 was just going to equal 1. So if we go ahead and write this over to the side here, that's just going to be 1w. Just go ahead and write the coefficient there just in case for now. So 1w is equal to, and then what's going to happen on the other side? Well, on the other side, we have to divide these two fractions, right? So if we go ahead and write this on the side just to be super clear, this is 51 over 2, and we're going to be dividing this by 17 over 3. So we can go ahead and rewrite this as 51 over 2 and multiply that by the reciprocal of this 17/3, which is going to be 3 over 17. Now you might not see this cross canceling right away, but remember 51 is divisible by 3 if you use your divisibility rules. So we can go ahead and divide these both by 17. We're going to get 1 and 3. Now if we go ahead and just multiply across here, we're going to get 3 times 3 is 9, and 2 times 1 is going to be equal to 2. So our width here is going to be 9 halves. Right? Now, if you want to simplify this a little more or rewrite this as a mixed number, you can. You can say the width here is going to be 4.5. And so we can conclude here that the width of this rectangle would be 4.5 meters long. Now, if you wanted to check this, you could take this 4.5 and you can go ahead and multiply it by this 5 2/3, and you should get this 25.5 square meters as well. All right, moving on to number 6, it looks like we have a problem dealing with statistics. It says find the sum of the mean and the median of the following data set. So the sum means we're going to be adding, but we have to find two things first here. So let's go ahead and see if we can find the mean first. So for the mean, let's go ahead and see. The mean means average. So to find the mean here, what do? We're going to take each of the numbers. To find the mean, we're going to add up all the values, find the sum of them, 5 plus 9 plus 6. That's going to be so far what? That's 20 so far, plus 2, that's 22. 22 plus 1 is 23. 23 plus this 12 here is going to be 35. 35 plus the 7 is going to be 42. So altogether, the sum here is 42. And when we find the mean or the average, we're going to divide that by how many numbers we have, which is 7. And so if we go ahead and write the sum of 42 over 7, we're going to see that the mean here is going to equal 6. Now, what about the median? Well, for the median, we have to write all the numbers in order from least to greatest here. So I'm going to go ahead and write 1 down. I'm going to go ahead and cross that out, actually. And then 2, I'm going to cross that out. Well, let's see, we have 5 and 6 and 7. I'm just going to go ahead and write those down, 5, 6, and 7. And then we have 9, and then we have 12. All right, so looks like those are all our values or observations in order from least to greatest. Now, if we want to find the median, let's go ahead and just find that middle value. So if we go ahead and do that, we're going to see here that our median is going to be 6. So this is going to be our median. Now, what were we asked from the beginning? I think from the beginning we were being asked to find the sum of the mean and the median. So if you want to find the sum, let's go ahead and just add these values up. The sum is going to be equal to 6 from the mean plus the 6, just kind of coincidental that was also 6, but that's going to be the 6 and 6 together. The sum is going to be 12. All right, here is number 7. For number 7, we're going to see how many of these little 0.5 centimeter cubes will fit inside of the rectangular prism below. And if you're not sure what they're implying about the 0.5 centimeter cube, keep in mind that this just means that we have this little cube here. They're only giving you one number because a cube has the same dimensions all the way around, but we have a length of 0.5, a width of 0.5, and a height of 0.5 as well. So now just to keep things nice and consistent, I'm going to go ahead and call this the length here. I'm going to go ahead and call this the width, which is this 3.5, and I'm going to call this one the height, and that's going to be this 7.5. Now, there are multiple strategies you can use to figure out how many of these cubes will fit in. What I'm going to do is I'm going to figure out how many cubes fit along each dimension here, and then multiply all those cubes together. So looking at the length first here, the length is 5, and I want to see how many of these little 0.5 cubes fit across there. So I'm going to divide this by 0.5 to see how many will fit. Okay. Now, if you take 5 and you divide it by 0.5, we're saying how many halves fit inside of 5, and I believe that's going to be 10. You can fit 10 halves inside of 5 holes, so we can fit 10 cubes across here. All right. Now, going in the next dimension, this is going to be the width. How many cubes can we fit along the width here? Now along the width, it looks like our dimension is 3.5 centimeters. And we're going to see how many of these little 0.5 centimeter cubes are going to fit alongside this 3.5. So how many halves will fit inside a 3.5? And I believe that's going to be 7. So I'm going to go ahead and say that there are going to be 7 cubes that'll fit along the width here. All right, finally, moving on to the height. This is how tall this prism is. The height here is going to be 7.5 centimeters, so 7.5. And we want to see how many of these little 0.5 centimeter cubes can fit stacked on top of each other. So how many halves will fit inside a 7.5? Well, I think that's going to end up being, let's see, I think it's going to be 15. Again, feel free to do the division, but I'm just going to go ahead and say that I think we can fit 15 cubes stacked on top of each other. And so if you want to find out the total number of cubes that you can fit inside of this right rectangular prism, that's going to be equal to this 10 multiplied by 7, so 10 times 7. That's going to be telling us how many cubes are going to fit along the floor or the bottom or the base of this right rectangular prism. And then we have 15 layers of these stacked on top of each other. So if we take that 10 and multiply by 7, we should have 70 of these cubes along the base of this prism. And if we multiply that by 15 layers, we're going to get a total of 1,050 of these cubes. This is how many of those half centimeter cubes we can fit inside of this rectangular prism. Here's number 8. For number 8, it looks like we have a numerical expression, so we're going to go ahead and just use the order of operations to evaluate this. So right from the beginning, let's see, we have some parentheses, so let's go ahead and just look inside those parentheses. They're going to go first. Inside the parentheses, it looks like we have addition, and we also have a power. Now the power is going to go first here. So I'm just going to go ahead and highlight what we're going to be doing in each step. So I'm just going to do that in this reddish color, right? So this 2 to the 5th power is going to get to go first here. Now on the side, just to be very clear, this 2 to the 5th power is really just 2 times 2 times 2 times 2 times 2. Now 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. So I'm going to say this is equal to 32. So going back to our problem, let's go ahead and take this 28 and subtract. We're going to have 4 plus this 32. We just evaluated that power. Keep it in parentheses because we still have another operation inside there to take care of. We have divided by 8 and then plus 7. Now, still keep looking inside this parentheses just because we still have an operation to deal with. So this 4 plus 32 is going to be 36. So at this point, we can go ahead and drop the parentheses because we don't have anything else to do in there. So it's going to be 36 and then divided by 8 and then plus 7. Between the 3 operations you see here, division is going to go first amongst them. So 36 divided by 8 here, looks like that's going to be a decimal. So if you want to evaluate this 36 divided by 8, you might realize it's not going to go in evenly, but it's going to go in 4 times. 4 times 8 is going to be 32. Now 36 minus 32 is 4. So you can say that this is going to be 4 and 4 is 4.5, or you can go ahead and add a 0 and a decimal and add this down, or bring this down rather, and that would be 40. So we can see here that this decimal version would be 4.5 if you prefer decimals instead. So we're going to have 28 minus, and that 36 divided by 8, or the quotient of that, is 4.5 or 4.5. I'm going to go ahead and write that, and we're going to go ahead and add 7. Now between subtraction and addition, they're equally important, so we just go from left to right. So 28 minus 4.5, well 28 minus 4 is 24, and taking away another 0.5 or half is going to be 23.5. So I'm going to write 23 and a half, or 23.5 plus 7. And now we just have one final step to take and add these two together. So 23.5 plus 7 is going to be 30.5, or 30.5. So putting this all together, we can see that this original expression is going to be equal to all these values right here. And so this would be the value of this expression. All right, here is number 9. In number 9, if 13 boxes of the same candy cost $55.64, determine the exact cost of one box of that candy. So let's go ahead and just define a variable here so we know what we're doing. I'm going to say let x equal the cost of one box. Cost of one box. Go ahead and just label that there to start. And so if we have 13 of these boxes, we would take 13 and multiply that by the cost of one box, and that would equal this 55.64 since they're all the same, right? So this would actually be a one-step equation. Now, if you want to find the price of one of these boxes, we don't want the price of all 13 of them, we should divide it by 13. So if we divide by 13 on both sides of the equation, 13 divided by 13 is just going to be 1. That kind of makes sense because we want the price of one box, or 1x. And on the right side, we have to do some division here. So let's go ahead and do some division on the side. We have 55.64 and divide this by 13. Now 13 won't fit into 5, but it does fit into 55 4 times. 4 times 13 is 52. 55 minus 52 is going to be 3. Let's go ahead and bring down the 6. 13 into 36 is almost 3 times, but I think we're going to have to go with 2. 2 times 13 is going to be 26. 36 minus 26 is going to be 10. Let's take this 4 and bring it down. And then 13 into 104, I think we're going to go with 8 here. 8 times 13 is exactly 104, and the remainder here is going to be 0. So 1x is going to be equal to 4.28. So we can go ahead and say that x is equal to 4.28, but remember, x represents the cost of 1 box of candy. So we can conclude that 1 box of candy is going to cost $4.28. Here's one final practice problem. In number 10, we're going to evaluate the following expression if x is equal to 4 and if y is equal to 3. And so whenever we see x, we're just going to replace it with 4, and whenever we see y, we're going to substitute in the value of 3. And so if we take this original expression, it's going to be 5 multiplied by x. Now we know x is equal to 4, so we're going to say 5 multiplied by this 4. Okay, and then we're going to say we have this 4 times y. Well, 4 multiplied by whatever y is. We said y was going to be 3, so let's go ahead and make that substitution. And this is going to be all on top of 11 minus whatever y is. Now, looks like, again, y is 3, so let's go ahead and make that substitution. Now, you can treat the top and the bottom as 2 separate problems, or you can go ahead and just put in parentheses. Keep in mind that there are invisible grouping symbols when you're dealing with fractions. And so if you go ahead and just look at them separately, you can just look at the top and multiply this 5 times 4 first. So 5 times 4, that's going to be 20. And then what we're going to have here is going to be 20 plus 4 multiplied by 3. That's going to be in the numerator, and in the denominator, since it's basically a separate problem or in a separate grouping symbol, you can actually do that in the same step as well. So 11 minus 3 is going to be 8. And if you keep going here, the numerator, you can also simplify 4 times 3 to get 12. So we're going to have the top as just being 20 plus this 12. And that's all going to be on top of 8. Then if we take this 20 and 12 and add them together, that's going to be 32. So we're going to have 32 over 8. And then if you go ahead and find that quotient, that's just going to be equal to 4. All right, so if x was equal to 4 and y was equal to 3, then we would find out that this algebraic expression would be equal to 4. All right, so there you have 10 different practice problems on reviewing some different types of concepts from 6th grade. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.